So, good afternoon. As you said, my name is Alex Knaus. I'm with DRDA, and today Jake Ann and I are going to be talking about data sharing, data management issues. I think kind of from our three individual or distinct perspectives representing the various roles and responsibilities we have at the university. Mine from working with PIs and facilitating sharing data, kind of going through the regulatory mess, putting data use agreements in place. Jake talking about projects that he's worked on throughout the university to put together solutions for complying with NSF's data management plan requirement, and the various projects that a couple different departments of the university have started and neared completion. And then finally, Ann is going to talk about one of her projects, and she'll be able to speak a lot more intelligently about it than I can, that seeks to put together an infrastructure of a sort for preservation and maintenance of data. So my particular wheelhouse here, like I said, is dealing with these regulatory issues. So managing data for sharing really comes down to specifically talking about these considerations that you need to take into account prior to collecting data, knowing that I'm going to have PHI or other sensitive, potentially proprietary types of data, or data that you're looking to share retrospectively, right? Data that somebody else or you have collected previously, and now you're looking to engage in some sort of secondary research. And so in that situation, what are all of these obstacles and hurdles that you need to negotiate when looking to share that data widely? So I'm assuming most of you guys have heard of or seen or are generally aware of this NSF data management plan requirement. So as of January 18th of this year, NSF has required that all proposals to them, all submissions, have to include a supplementary document of no more than 2 pages labeled a data management plan. And this data management plan should describe how the proposal will conform to the NSF policy on the dissemination and sharing of research results. Now, this, as I'll talk about later, this isn't the only occurrence of these kind of federal mandates, but it's the one that I'm kind of use as our frame of reference throughout, because it's the most recent, and arguably it's the one that's going to be the most rigorously reviewed and audited. But so what is the NSF policy on the dissemination and sharing of research results? Well, NSF has noted that investigators are expected to share with other researchers within a reasonable time the primary data, samples, and other materials created or gathered in the course of work under NSF grants. Grantees are expected to encourage and facilitate such sharing. So, if you go back to this, so the data management plan is supposed to facilitate compliance with NSF's policy on dissemination and sharing. The dissemination and sharing policy is you're supposed to make yourself available if we fund it. So ultimately, NSF's data management plan, or data management in general, equates to data sharing, right? That's ultimately what we're trying to reach. Why do we care about you making sure that your data is going to be maintained for a long time? Why do we care that it's going to be in formats that are readable in the future? It's because we want you to be able to share that with other people. And now, like I said, NSF might be the most recent, but it's definitely not the only federal funder who's required this. So any of you who deal with NIH know that since 2003, they've required that all proposals to NIH seeking funding more than $500,000 in any 1 year required the inclusion of a data sharing plan. And that this plan is to facilitate NIH's position that we believe that data sharing is essential for expedited translation of research results into knowledge, products, and procedures to improve human health. So NIH has had this requirement in there since, like I said, 2003. Now, it hasn't been particularly rigorously reviewed. We haven't, as far as we know, had proposals rejected because they thought the data sharing plan wasn't sufficient, or we've had NIH come in and audit compliance afterwards, which is what we believe NSF is eventually going to move towards. Additionally, in the last couple months, I've seen the Environmental Protection Agency include this language, noting that any plans in response to this particular RFA had to state how all the data resulting from the agreement will be made usable by others in the scientific community, including both primary and secondary and existing data collected or used in the agreement. So you're talking about also data, and NSF kind of reaches to this level as well, data that you might have gotten from third parties for the purpose of doing your project. So, you can see right there the complications. Well, under what restrictions did I get that data from that third party in the first place? Am I going to be able to meet these obligations? So these are the kind of things that you're going to have to think about when you decide, well, I'm going to write my data management plan or write my response to the EPA. And so why? Why are we seeing all of these public funders moving towards this, this position? Well, it's because there's this general recognition that publicly funded research should result in publicly available research data. If we're giving you money to do something, we want that data to be as widely available as possible. And of course, not all of the reasons or not all of the incentives for engaging in data sharing are because they're mandated, right? Well before NSF, well before NIH put these kind of requirements in place, researchers have engaged in kind of this collegial data sharing. Whether it's because they want to build larger sample sizes to analyze rarer conditions, to reproduce research, to vet the results against. A majority of the time that or majority of my work within DRDA is putting in place data use agreements to facilitate this type of collaboration. It's not because NIH or NSF mandated it, it's because the researchers want to participate in this collaborative research. And of course, as these collaborations become more and more complex, you get multiple parties, you have sites choosing to operate as a data coordinating center. The complexity of that legal relationship increases exponentially. So again, going back to the NSF mandate, because that kind of gives us this frame for what we can expect as kind of the standard for these mandates going forward. So in general, they note that a data management plan is required always, even if the funded project is not expected to generate data. Now, your data management plan might say, no detailed plan is necessary because we're not going to have any data, but you better be able to justify that. And the reason you need to justify that is because the DMP is not just some supplementary document you slap on. They say, yeah, you've got it, this is good. This is going to be something that ultimately is going to be reviewed as an integral part of that application. Now, we haven't seen any data, and actually Jake or somebody else might be able to speak as to whether or not they've seen any, actually I guess DRDA would be the best place, so I'm not going to punt it to him. So we haven't seen any situations where NSF has said, we're rejecting this proposal because we think your DMP is insufficient. But we've been put on notice that eventually that's where we're going to be. So you don't have a sufficient data management plan, you could potentially lose out to somebody who did a better job of articulating the issues surrounding that. Some of the NSF directorates have provided individual level guidance for what they expect in a data management plan. And since I did this type of presentation just a couple of months ago, this list has increased. So it's taken them a little while, but these directorates, it looks like they are slowly moving towards providing individual level guidance for all of them. And so this is the first place that you want to look to try to figure out what your obligations or what your data management plan should look like. This is the first layer of guidance. But in general, the grant proposal guide from NSF notes that these are the types of things that should be covered. And I'm just going to skim through them real quick because Jake is going to speak a bit more about putting together an excellent data management plan that will never be rejected. And that was supposed to be funny. So these are the types of issues that you're looking to cover in your DMP. So number one, what type of data are you going to be collecting or generating? What sorts of data formats, what types of metadata need to accompany that? What your policies are for access by third parties and sharing that data. What your policies are for reuse, redistribution, the creation of derivatives from that data. And then your plans for archiving and curating the data and samples going forward. So you kind of have three chunks. What kind of data, how are you going to make it available to third parties, and how are you going to make sure that this data is available going forward. So it's kind of a rough breakdown, but in general I look at these things as technical limitations and compliance. And compliance is a really bad term to use here. Simply because it covers things that are more than regulatory compliance issues, but they're really kind of all these non-technical areas, and this is kind of my wheelhouse. So the technical considerations, and again, Jake will speak about this a bit more, but what types of data formats, what your disaster recovery plans are, how often your system backs things up, where you're going to actually store it, and when trying to identify your technical solutions, you have two options. You can either find something that's pre-existing and say this is what we're going to use, and maybe that costs a certain amount of money to use that, or you can propose to build a solution. Now, the problem with building a solution is if you throw in a budget that's large enough, then that might be a reason why NSF rejects your proposal, because your competition has figured out a cheaper way. But so, compliance, my area. So these are the kind of issues that you need to think about when you're talking about sharing your data. And now some of these won't apply depending on your particular domain. But we've got common rules, so human subjects type limitations, FDA regulations, HIPAA, so the HIPAA privacy rule, IRB considerations, the policies of your particular institution. Maybe they've got research policies in place that will impact your ability to share. Funding and other contract type restrictions. So like I said before, your funder or the provider of that data, did they provide that money or those materials under some sort of agreement that's going to limit your ability to do something with them later? Institutional interests, so do we have a particular interest in data or materials that's distinct from kind of these regulatory standards that we need to account for? And then publication and intellectual property issues. And unfortunately, government really provides no help here whatsoever. So NSF notes that privileged or confidential information should be released only in a form that protects the privacy of individuals and subjects involved. But there's no suggestion as to what that form is. And unfortunately, determining what that form is the subject of rigorous academic debates right now. Privacy advocates versus kind of open data advocates clashing with each other, trying to determine what those standards are that both protect the interests of the subjects but also facilitate this widespread sharing of data. And NSF notes that what they consider reasonable access to data containing sensitive information is going to be determined by the process of peer review and program management. So in other words, it's up to you guys. We'll know, it's kind of like the Supreme Court, right? We'll know what a good standard is when we see it. And that's, and so they're pushing it back on us to set good standards. NIH is similar to NSF. They note that data sharing may be complicated or limited in some cases by institutional policies, IRB, et cetera, including the privacy rule. So again, they recognize that these could be limitations, but they don't tell us how to circumvent these limitations. So real quickly, the kind of issues that you'll see within this compliance domain. So privacy and confidentiality, dealing with HIPAA, for instance. So do you have PHI in the first place? University of Michigan, for instance, nearly every department, well, I guess the medical system, the dental school, school of public health, you're doing any research in there, in all likelihood, you're dealing with PHI of some sort. So we have to determine, do you have PHI? If you do have PHI, do we need to de-identify it, remove some of the identifiers, put a data use agreement in place? What do we need to do to allow you to share that PHI with others? Human subjects issues. So is the data derived from human subjects? Well, if we completely anonymize that data, then it's no longer human subjects data. So the common rule, these IRB type restrictions, they go away. IRB just waves their hand out and says, do whatever you want to with it. Ultimately, you might need to go down to the consent and look to determine, well, does the consent explicitly allow us to share data, or does it explicitly forbid us from sharing data? If it's somewhere in the middle, we're going back to the IRB. We're requesting a waiver to try to get around that. And then IP and publication issues. So NSF notes that in terms of intellectual property, they'll allow the grantees, us, the funding recipients, to retain IP rights developed under NSF grants, but that doesn't remove our obligation to still make that data available. So maybe we have to do it under a non-disclosure agreement, but we're still obligated to share the data to a certain extent. They're not simply going to say, well, yeah, you have an IP interest, you want to develop this into something, so you're completely free from having to share any of the materials generated. And then in terms of publication, NSF notes that you can delay publication or you can delay release prior to publication, but within a reasonable amount of time, that data has to be made available. And again, what's considered a reasonable length of time is going to be determined by the community. So trying to navigate all of these, these complex issues is what you're doing when you're putting together a data management plan. And again, remember, this is me just talking about kind of the compliance issues related to it. The technical limitations, completely outside my wheelhouse, and that's something that, hopefully, Anna will be able to speak to a little bit. But in terms of putting together a successful data management plan, that's what Jake will be talking about here in just a moment. So just to kind of put in a plug here. So for any of you who find yourself in a situation where you're required to navigate this kind of complex regulatory situation, either because you're putting together a data management plan and you think these issues are going to come up, or you've decided that you're engaging in some sort of collaboration, or you're requesting data from a third party who's saying, well, you got to sign this data use agreement before you can get it. The Data Sharing Resource Center is this project I've started up within DRDA that's specifically aimed at providing expertise and kind of carving out a subject matter domain related to this issue. So it was launched last summer primarily in response to the NSF mandate, but for the most part, like I said, most of my work has been involved with negotiating data use agreements to allow data to be shared amongst parties, Michigan outside or outside into Michigan, in compliance with all of these various issues. So that's my contact information. The website, unfortunately, is still almost completely unpopulated after a year, but I'll get to it at some point. But yeah, so absolutely feel free to contact me at any point afterwards, and then we'll be taking questions after this. So thanks.
All right. There we go. Thanks, Alex. My name is Jacob Glenn. I'm the librarian for physics and astronomy at the Shapiro Science Library. And for the past several months, I've been working along with Alex and a bunch of other people in the College of Engineering to develop data management plan guidance for PIs who are writing proposals for the engineering directorate of NSF. So now that Alex has set the background, I wanted to maybe dig down into the nitty-gritty and talk about sort of a case study in developing this guidance and look at some specific examples of plans that we've seen. And I want to start by telling you where the effort came from, talk about some issues that we faced when we were putting together our guidance for PIs, how we addressed those issues, and some what I consider to be problems with the way we address those issues and how I wish we could have addressed them instead. And then I would like to say a little bit about the kind of institutional support that I think we would need in order to be able to do that. And then I'll end by talking about 2 or 3 promising projects that are going on at U of M that I think are going to take us in that direction. So the ad hoc working group in the College of Engineering was started a little bit over a year ago, and it was something that was originally got together by George Karanen, who's since stepped down as Associate Dean for Research and Grad Education. Alec Gallimore is his successor. And it really came out of the LS&A approach to dealing with the NSF data management requirement, which was basically to put it on the IT departments to vet these plans. So there was some discussion, I think, although I wasn't involved at this stage, but from what I've heard, there was some discussion between the Office of the Associate Dean for Research and Kane about whether this was the right approach for the College of Engineering. And as a result of this, a bunch of people came together to sort of address these issues and figure out what the best approach was for the college as a whole. And eventually, we decided that our main deliverable was going to be a template for PIs to provide guidance for the writing of these data management plans. So this is the current roster. Alec Gallimore, Paul Kelly, of course, is the director of Kane. Linda Forsyth from COE Research Administration. Alex, Elizabeth Wagner, also from COE Research, and then myself. So the starting point for our discussions was really just the fact that Research Administration was getting lots and lots of questions about these new plans that no one knew how to write. And these were some of the most common questions that PIs were we're having. First of all, what data do I have to share? And this is not as easy a question to answer as we would like because it depends on who you're proposing to. The NSF does not have one definition of data. They sort of delegated that along with everything else to all the NSF directorates and divisions. So they all have slightly different definitions of what data are. How soon do I have to share? Can I wait till after I publish? That, again, has a wide variety of answers depending on who you're asking. For how long after the end of my grant must I continue to provide access? In the case of the engineering directorate, that's a minimum of 3 years, but again, it varies. Where can I store the data? That's the hard question, and we'll get back to that. If you're lucky, there's already a disciplinary data repository or an institutional data repository that you can put it in, but in many cases that's not true. I already published data in journals. Does that count? I'm a librarian, so I'm biased. My answer to this is no, not really. At least it shouldn't be the only place you're putting it because, for one thing, publishers go bankrupt, journals go under, and for another thing, there are a lot of people in the world who probably can't get to that data because the journal is behind a paywall and maybe you and your colleagues can access it, but to virtually everyone on the planet, it's completely inaccessible. And so it doesn't really answer what I think the NSF requirement is truly getting at, which is public availability of data. How do I budget for storing data after the grant is over? Another big, hairy question that I'm going to try and address in a little bit. I can't share my data because, where the because is usually followed by something having to do with privacy or confidentiality concerns and or IP concerns, which is more common in engineering. And of course, the engineering directorate makes lots of allowances for those sorts of things, but they do need to be addressed explicitly in the data management plan. And of course, the perennial favorite, question 8, can't you just give me some text I can copy and paste? And my answer to that one is a qualified no, but I'm going to spend most of my talk actually addressing the nature and extent of the qualification to that no, because I do think boilerplate can be very useful in the writing of data management plans if it is used appropriately. Unfortunately, it is more common for it to be used inappropriately. So our group initially was meeting once a month, and we've since been meeting a little bit less regularly since we've actually released our template, and we're working more now on implementing some of the things that are recommended in the template. So there are a lot of these NSF data management templates now. This is one from Purdue University, and I don't intend to denigrate it in any way by putting it up with the heading, "The Problem with Templates," but it does illustrate what I interpreted as some of the shortcomings of a lot of the templates that have been released. And I think this is a very good one, actually. It was the basis of the one that we ended up putting together for the College of Engineering. But as you can see, it's basically a list of questions, as most of them are. So under data access, are existing data repositories suitable for hosting your data sets and making them publicly available? If you don't have an existing repository, that is a disciplinary repository, what methods, infrastructure, systems, et cetera, will you use to share your data? Those are all really good questions that, that need to be asked, but unfortunately at the stage where researchers are preparing their data management plans, they often don't know the answers to these questions and don't know what would constitute a good answer or a bad answer. And so, you know, to the question, if you don't have an existing repository, what methods would you use? The answer is likely to be something like, well, I'll put it on CTools, or I'll burn it to DVDs and I will stick them in my desk drawer. These answers are more common than you might think, and they're not good answers. So what we wanted to do was really to create an opinionated template that would offer some actual opinions on how you should answer those questions instead of just telling you what questions need to be asked. And this is how we did it. This is a shot of my desk covered with data management plans. I was fortunate enough to work with some research administrators in the College of Engineering who provided me with reams and reams of these things, over 100 of them. I haven't actually counted them. And I sat down and I read them and I took a lot of notes. And I wanted to illustrate, not just provide boilerplate text, but illustrate what a good answer and a bad answer looked like by means of actual examples taken from actual plans. And so that's what the process looked like, and what I ended up doing was pulling out a lot of the most common problems that seem to be cropping up over and over again in these plans. And so here are some of them. And these may sound familiar to those of you who are in positions where you have to read these plans. In difference to formats that are standardized, so standard formats are very important in data preservation. It's important to encourage people to avoid the use of proprietary data formats that rely on some specialized piece of software or hardware to read them. No understanding of metadata, that's not surprising to me as a librarian. No one knows what metadata is. Some people think it's computer code. Some people think it's a text file describing what's in their spreadsheet, which is better than nothing. Some people think it's a journal article describing their methods, which it's definitely not. So there was a little education that needed to happen in our guidance with respect to what metadata actually is. Lack of distinction between backup and archival. So backing up your data to the network attached storage and leaving it in the dark for 3 years is not data sharing, but some people think it is. Lack of awareness of licensing, I'm very sympathetic on this one. I'm not a lawyer, and neither are most researchers. And there are a lot of legal intricacies involved in the licensing and sharing of data, as Alex discussed. But we found that since most people don't have the patience to delve into those legal intricacies, it was desirable to provide a default set of licenses that could be applied to cover most cases in which there was no monetary interest in the research products, so that we could just point people to a license and say, use this. Confusing journal publication with data sharing, that's very common, and unjustified and unnecessary restrictions on data availability, saying, I will make my data available upon request, is okay if you justify that, but it needs to be justified because, again, the NSF mandate gets at public availability of data in an unmediated way. There are lots of reasons why you might need to limit that, but you need to address those reasons in the plan. And then, of course, failing to address all parts of the DMP, also very common. So this is a screenshot of the template, and it's kind of hard to see. I'll show a closer one in a minute. Basically, this is just the document design. It's a little bit different from the list of questions format. It's got 2 columns, and you can see that the left column is very similar to the list of questions format. It starts with a reference to NSF documentation with a link to the full documentation. There's a little summary for each section. Then there's a question, but then after the question, we have examples. The examples are color-coded. I've been told that people with red-green color blindness are going to have a hard time with this, so I might have to change the colors. But basically, green is good and red is bad. Initially, I was planning to include one good and one positive, I should say a positive and a negative example for every question. But since a lot of these questions have multiple facets, it turned out that we needed to include multiple examples for most questions. And then in the right column, there is a heading, which you probably can't read, called Resources and Commentary. And basically, that's just a column for links to additional documentation as well as commentary on both the questions and the examples. And the commentary on the examples turned out to be very important. I didn't initially plan on putting that in because I figured that it would be self-evident why this was a good example or a bad example, and it turned out it wasn't quite as evident as I thought it would. So there's a lot of attempts to explicate that a little bit. So the strategy is basically draw the outline of a good answer and a bad answer without really providing a single standardized piece of text that you can put in there. And this is just one example from the data archiving section of the template. So the question is, which archive, repository, database have you identified as the best place to deposit your data? That should look familiar. That's basically an adaptation of the question from the Purdue template. But then over here on the right, we've got some links to lists of data repositories and then the examples. So the good example, upon finalization, the calving histories we derive from satellite data will be submitted to the National Snow and Ice Data Center. That's astonishingly rare to see someone actually identifying the correct data repository for their stuff in their plan. So this is a rare gem that we wanted to include. And then below that, it's actually from the same proposal. The infrastructure provided by NSDIC is not yet either designed or suitable for distribution of software. So we're going to release and distribute GPL versions of our software as tarballs from our institutional website. That's included as a positive example, and it illustrates a limitation of this approach in that I didn't really have space to address some of the negative aspects of that. I mean, if you're going to be distributing your software, it's probably not the best thing to host it from your institutional website, but doing it is good. So we wanted to illustrate that this is something that should be addressed in the plan, but I just didn't have space to look at some of the less favorable aspects of it. And then the negative example below it, at the end of the project, original laboratory notebooks will be secured by the PI in his campus office. Computer files will be stored in the form of hard drives as well as on cTools. That's a more common sort of answer that you see to this question. So now I want to talk a little bit about boilerplate. And this is one thing that PIs always asked for. It was one of the most commonly asked questions going in, as you remember. And I think this is a totally reasonable request. In fact, I say the less of the data management plan the PI has to write, the better. And the reason for this is because if we don't give them boilerplate, they're going to come up with their own. And I've read enough of these things now to know that there is lots of recycling of text that is going on. So PI writes one data management plan. In every subsequent plan, they're just going to copy and paste most of it in there and maybe make some little adjustments for the particular project. And that's great if their first plan was really good. But if it wasn't really good, then their subsequent plans are not going to be very good either. And this phenomenon is not limited to excellent data management plans in my experience. So I think it's in everyone's best interest to provide effective boilerplate to the extent that we're able to do so. What we gave them instead was a 30-page document full of examples and links to documentation. This is a really big, scary document. It's not something you're going to read the night before your proposal is due and write the best data management plan ever. It could be a big deterrent, I think, in the sense that if you're on a deadline, which people frequently are, you might just decide to email your colleague and say, hey, do you have a plan that I could use, which might not be the best thing. So this is a problem. Why did we do things that way? Well, in part because there's a challenge inherent to writing guidance for the entire college. There's such a huge diversity of research that's going on, even in one college, that it's really hard to provide boilerplate that works for everyone. But also, I think there is a huge potential for misuse of boilerplate, which we're going to look at here. So does anyone recognize this piece of text? Okay, Anne does. Someone else does. Yeah, this is from the ICPSR framework for creating a data management plan. And this is a great piece of boilerplate to use if you happen to be collecting survey data for your research project. In fact, I would say the ICPSR framework is an excellent resource for anyone who is creating data that is of the sort that would normally be curated by ICPSR. Problem is, this wasn't taken from a proposal that was collecting survey data or indeed any kind of data that could be personally identifiable. This proposal was for the collection of ice cores in Antarctica. Now, what does that have to do with personally identifiable information? Nothing. So why did they include it? Well, I suspect that they just didn't know what to put there, so they went online and they found something that they could put there. So this is a big problem. If I were reviewing this proposal, that would be a red flag to me that says this person didn't take the DMP seriously. At least that is the most charitable interpretation I can think of. So that's an example of how boilerplate can be misused. Let's see some really good uses of boilerplate. These are all taken from the same proposal. It's from a researcher at the U of M Biological Station. As you may know, the UMBS has been putting a lot of effort into developing their data management infrastructure, including software. They have their own repository based on Drupal. They've got a data manager, that's Kyle Quaiser, They've got a lot of standard policy that they've developed. And they can do this basically because they're very centralized, and the research is done at one location, so they can maintain pretty tight control over how it's managed. So you get this great data management plan that's got stuff like, the UMBS Research Gateway will be used for providing long-term public access to the data sets. Policies provided by UMBS will be used to guide metadata and data sharing. Per the UMBS policy, all data sets will be deposited within a year of completion, and then this actually ended with, I think, a link to the full policy. I will work closely with the UMBS Information Manager to ensure metadata completion and quality assurance of data files. The whole proposal basically reads like this. I think it's pretty much all boilerplate. I would have to check with Kyle on that. But it's great. It's one of the best plans I've ever read. So you can use boilerplate effectively if the services are there to support it. The challenge is, how do you do this for a research community of the size and diversity of the whole university? Or even for a medium-sized department when there's not that sort of tight control that they have at a place like the BioStation. And that's a really good question that I'm going to try to address here in a little bit. I want to show another good example that kind of hints at where I'm going with this. This is from the University of Virginia Library, which has a division called the Scientific Data Consulting Group. And they are putting together data management templates for every NSF directorate and division that has issued guidance, which I think is about a dozen of them by now. And every single one of those templates has the same piece of boilerplate in the archiving section. As advised by University of Virginia library staff members, I plan on depositing my research data in the UVA Institutional Repository, LIBRA. I will submit the necessary metadata, etc. In accordance with the university policy, the data will be preserved for a minimum of 5 years. However, the current preservation plan is to preserve it indefinitely. So UVA is pouring a lot of resources into the development of this institutional data repository. And because they're doing that, they can provide this standard boilerplate that ties into their standard service, and everyone can use it. And it is always appropriate, pretty much. There are some issues here. I'm made very nervous by this line about, I will provide the necessary metadata. When you have researchers taking responsibility for providing the metadata, there's a question of who's going to make sure that that happens. And so I think there would need to be, in addition to a standard service like a data repository, there would need to be services for people who are using that to make sure that they use it correctly. But anyway, this sort of hints at a few goals that we could aim at in the interest of enabling effective boilerplate for data management plans. And I'm aware at this point that I'm putting the cart entirely before the horse. But since I got into this whole thing about data management from the perspective of creating guidance for people writing data management plans, that's sort of how I look at it. Of course, data management done well is a worthy goal in its own right. So I'm going to call these the 3 pillars of effective boilerplate. And the first one is standardized services, as illustrated by the UVA example. By services, I'm referring, first of all, to IT services that are the infrastructure that underlies data management, but also to the services that are directly aimed at users. Okay, if I'm down to 1 minute, then I'm going to have to skip some stuff. Sorry about this. Second pillar, just local norms, and here I'm talking specifically about policy, standardized institutional policies for things like data retention periods, access and sharing, licensing. Those things, obviously, there needs to be a lot of wiggle room, but there, I think, is potential to provide good defaults on a university level. And then the third pillar, which is really sort of a meta pillar, is just organizing for research data management. And this just means having the right connections within the organization as a whole to support the coordination of all the services that it takes to be able to do data management really effectively. And this is an example from Cornell. It's not intended to be prescriptive. It's just an example of what a lot of universities are doing to reorganize themselves around support for data management. And building these at I'm going to skip over these really quick because I'm out of time, and you all probably know about most of these. First of all, there's NextGen. I've been privileged to participate in a little bit in one of the groups, the Data Storage Strategy Working Group, which is working on the storage component, and that includes goals for things like information lifecycle management and long-term archiving, which I think will go a long way towards providing the sort of standardized services that we need backing up the creation of these plans. There's the LSA data classification tool. This is a screenshot of the paper version. This is currently being turned into a web-based decision tree that's going to help researchers classify their data to inform the decisions that are made by the IT managers when they're provisioning services to use for managing that data. DMP tool is a collaborative project. ICPSR is a partner on that. And I think this has the potential to become a useful tool for collaboration among all the different units that need to have a hand in provisioning services to support data management. And now I'm going to turn it over to organize themselves around support for data management. And building these at I'm going to skip over these really quick because I'm out of time, and you all probably know about most of these. First of all, there's NextGen. I've been privileged to participate in a little bit in one of the groups, the Data Storage Strategy Working Group, which is working on the storage component, and that includes goals for things like information lifecycle management and long-term archiving, which I think will go a long way towards providing the sort of standardized services that we need backing up the creation of these plans. There's the LSA data classification tool. This is a screenshot of the paper version. This is currently being turned into a web-based decision tree that's going to help researchers classify their data to inform the decisions that are made by the IT managers when they're provisioning services to use for managing that data. DMP tool is a collaborative project. ICPSR is a partner on that. And I think this has the potential to become a useful tool for collaboration among all the different units that need to have a hand in provisioning services to support data management. And now I'm going to turn it over to Anne, who is going to explain the SEAD project and how that fits into the picture. Thanks.
Interesting, we all called our presentations CI days. Okay. Could I just do a quick check to see how many people here are, what do I want to say, I call them domain researchers, but somebody in like physics or material science or ecology? Okay. And other people are in information science or computer information science, information technology? Okay. Just kind of wanted to get a sense of who was out there. I think I can speak to both, to all sets, hopefully. So the data management plan approach that Alex and Jake talked about is an attempt to get researchers to think about the long-term management and preservation of their data. And with the sort of thoughtful approaches like Alex and Jake are taking to this data management plan idea, I think that it can result in some positive change. But as someone who has studied the sort of social and technical issues around data sharing for a number of years, I'm skeptical about a sort of mandated approach to data sharing and data curation. I think the best type of data sharing, management, and reuse happens when it's driven by the needs of the research and when it fits with the practices of the researchers. So, for example, large data collections, tools for working with data, standardized metadata practices and stuff are more common in say, it's not possible to do climate research without having access to global climate data, and those data are not owned by any one person or institution. So I think that's an example of a place where infrastructure exists because it's necessary to do the science. Oops, did that change? Bear with me a second. There we go. So as Jacob's presentation in particular also showed, there are many challenges with data management plans. So for one, they presume that all or at least most research data is worth preserving. In my mind, this is a questionable assumption. Out of the universe of data generated, only a portion may be worth the effort to preserve. Admittedly, it's hard to anticipate what those data are. I think, though, that we need to find other ways to figure this out than through sort of a shotgun approach. Data management plans also treat all data as if they were the same. But there are actually many different kinds of data, and those kinds can vary based on, as Alex was saying, the kind of intellectual property issues, privacy issues, confidentiality issues, as well as being experimental data, survey data, sensor data. So it's also the case that data aren't simply the end products of research, that they are something that evolve over time. So think about data that come off of a sensor. Those data are then post-processed in some way, and then perhaps they end up in some version in a publication in a journal article. Whereas data management plan sort of treats all of these things the same. Another issue that came out in Jake's presentation is that there needs to be an infrastructure that facilitates the management and sharing of data. And there are many aspects to this infrastructure, as he also talked about. There's tools to work with data. There are places to deposit data. One of the biggest challenges, I think, as he pointed out, is that in many research areas, there isn't just a place for you to put your data that other people can get access to. There also need to be human resources. So again, this infrastructure has to exist in many different kinds of ways. So NSF being, the people who sort of developed the data management plan approach, and NIH as well. I know most about the NSF approach. But obviously, NSF is filled with a lot of smart people, and a lot of those people are researchers themselves who come from the domains that they're mandating these data management plans for. So I think they recognize that this is just one approach to getting people to think about data sharing and data management. Another approach that they've taken is in the mid-2000s, late 2000s, they started a program called DataNet. And the goals of DataNet were to sort of, as you see listed here, to sort of develop a new type of organization to think about data, and that they would integrate expertise from all of the different areas that you need in order to deal with data management effectively, including people who are part of the research domain in which the data are generated. So it's about trying to provide preservation, but it's also about trying to meet user needs. Needs are not the same in every domain. So it's a very large scale approach, and that incorporates research as well to try to get to deal with some of the tough things that have been talked about. So now I want to move on to just talking about one of these projects within the DataNet program. And I want to do that in a way that I hope will connect, not to just talk about the project for the sake of talking about the project, but to talk about it as a way to address some of the challenges that have come up so far. So each of the data nets that have been funded, and there have been 5 funded so far, 2 were funded in 2009, and 3 were just funded this fall. Ours is one of those is based here at the School of Information. We'll talk just a little bit more about who's involved in it in a moment. But each of those has a sort of research problem area that it focuses on. And SEED, which stands for Sustainable Environment Actionable Data, is focused on the science of sustainability. So sustainability is sort of a new and kind of growing area of research that looks at the interactions between nature and humans. And if you've been following some of the stuff going on campus, you know that President Coleman has a pretty active initiative on campus sustainability. So the interactions between nature and people are very complex. in most cases. So for example, where people choose to live impacts how the land is used in a particular area, or how the land is used in a particular area might choose will affect whether people live there or not. So knowledge about these interactions is very important for environmental reasons, social reasons, policy reasons. And understanding them requires data inherently from many different domains and many different scales. And so it's a kind of a rich area. It's an area where naturally people want to find and reuse and integrate other types of data. But there are a number of challenges in this sort of a large problem space of sustainability science. And that's that you have many different disciplines, so you have many different cultures of sharing, you have many different types of data, you have survey data, you have environmental data, so you have social data, physical data. You have lots of small data sets. You might have a few large data sets. So Jake talked about ICPSR, the Inter-University Consortium for Political and Social Science Research, that provides access to a lot of large ongoing long-term surveys. So you do have those kinds of data sets. But what you also have are many individual small group investigators who have, had those kind of, what I actually have, notebooks and interview transcripts and things that are just, me working on a particular project. There's no place to really deposit those things. And there's just heterogeneity in every conceivable fashion. So another way to kind of think about this problem is what we call the long tail, and you've probably heard about the long tail in other contexts. So you have many small data sets gathered by many individuals or small groups of people, and that together makes up a majority of the data that are there. And so while the aggregate demand for data in general may be large and growing, the demand for any particular data set may be very small and very focused. So to try to spend a lot of money, a lot of time managing those data in a very kind of heavyweight way through a data management plan or something, for example, seems to be a little bit off in terms of cost versus value, perhaps. But at the same time, if you could get access to those data and you could combine them together, you could have something potentially very valuable. So it's a matter about sort of balancing the amount of time that you put into curating these data versus and money that you spend versus their sort of value overall. So often people think of Amazon as an example of something that can make you can have a book and you can put it on Amazon, and that way people can find it, even though the demand for that particular book overall may be small, it's findable through Amazon, where they sell many bestsellers, but they also sell things that are out in the long tail. So there's some of us who've been working together for a while and been kind of interested in this particular problem of long tail data, where you have many very heterogeneous data sets, many small types of data sets. And in the spirit of the DataNet program, we come from many different areas. So Margaret Hedstrom is the PI here at the University of Michigan School of Information. Margaret is an archivist background, particularly focusing on digital preservation. Then we have computer scientists, information technologists. Praveen Kumar is a scientist working in the area of hydrology and science of sustainability in general in Illinois. So we have a very interdisciplinary group ourselves, and we also have involvement of ICPSR here on campus. So I'm just going to, the goals and strategy that we're kind of using in SEED are kind of a bit of mother and apple pie at this particular point in time. We just got funded on October 1st, so we're a project, there is no system for me to show you. What we have is, I think, some sort of what I think of as concepts that drive SEED, that try to address some of the challenges that I've talked about. And so we are in this, so I'll just kind of show these next two slides, the kind of goals and the strategies, but then kind of just talk through some examples of, an example of kind of what I mean by that. Because SEED doesn't really exist and because it's critical that we develop it with people who would be the potential users of it. How it's actually going to look in, say, 18 months from now is very much an open question. So we have, as I'll say at the end, we just started. We have 18 months to develop a prototype in. And so during this first 18 months, we're kind of focusing on these 3 goals. The thing I just want to emphasize over and over again that we emphasize in our project, that it has to be built around the needs of people who would be the users. Beyond that, we have this active and social curation idea, and I'll talk a little bit more about that in a minute. And then lastly, there's a sort of long-term preservation component part to seed. So there's basically 3 different parts. One is making sure we build something that's usable to the potential users of the system. And there's active and social curation and long-term preservation. I'll spend most time on the second part. So part of the strategy, and again, I'll talk more about this, but the time when most of the information is known about data is when people are working with it, when it's being generated, when it's been collected, when people are analyzing it. And so if you want to try to capture metadata, the best time to do it is when people are actively working with it. But if you ask people to fill out long forms and describe their data and stuff, it's probably not going to happen. So we want to try to have ways to capture that information, but in a lightweight way so some of it can be, metadata can be captured automatically. Some of it can be, input, but not in a way that takes you 3 hours to do. So the idea is that we try to capture as much of that information while people are working actively with the data as we can. So instead of thinking about what you do with your data at the end of your study when it's all over, you think about it beforehand. Again, just talking about having research areas are different. And so there isn't a one, the boilerplate kind of problem that Jake talked about. So let me talk a little bit about this active and social curation notion. Again, it's partly working with people and with data while they are actively working with them. And using information to automatically capture it so it can be available later. If you can do some of these things in a more lightweight way than filling out a long data management plan or something, you can save, try to balance that cost versus value. So let me just kind of give some examples of what we envision that how seed might work. So you could have, as I said, the kind of part where a scientist has data, maybe they have a collaboration with people, and that is data that they're working with within the collaboration. They're not sharing it outside of it, although they could choose to if they wanted. So we're trying as much as possible to build off of existing tools, because we simply don't have the budget to develop a whole brand new set of tools, but we want to use things that are lightweight, that people can use, that add value to them while they're working with their data. So that's kind of one part of it. The other part of it is that people choose to share, or people find data from multiple sources. They create an aggregated data set from that. They can contribute it back into this active repository where other people can sort of, right now there's very often, you might deposit data that you've generated yourself in some sort of repository, but not very often do you see the sort of aggregated, consolidated, other products that people create out of having integrated data together. So this would be another place where people could contribute those kinds of data products back. People could use those, comment on them. So there's sort of a facilitating use piece of this. People can also find data or find people who have collected data. So there's sort of multiple connections, a kind of social network, data network collection, so that you can find data that other people have used, find out how they used it, trace back to see who else has used those data, who is that network of people that those people work with. So just many different ways to find, learn, find data, find people. And then we think that, one of the problems I talked about at the beginning is that there's this problem of what data should we retain? What data are worth, are valuable for the long term? What data maybe you could benefit from some more structured metadata, have ongoing use for the long term, whether that's 3 years, 5 years, 10 years. We think we would like to, it's always hard to answer that question, and I've talked with scientists and they say, well, it's hard for me to know what data might be useful. I mean, sometimes they can answer that question. Sometimes it's really hard to know. But our goal is to, within the sort of context of SEED, to let researchers answer that question for themselves as a community, to try to determine what data have ongoing value. And some of that will come from seeing what people reuse and contribute back. But once there's been a scientist or some maybe community of researchers in a particular area decide that something is worth preserving, there will be a mechanism to take data from the active content repository, the sort of short-term active place, into longer-term repositories. So, trying to give people a place to put their data for the long term as specified in the data management plan types of things. And our goal for that is to use the library institutional repositories. So Jacob was talking about the University of Virginia institutional repositories. So libraries are getting very interested in the management and preservation of data. And so we would work in partnership with libraries to become sort of the longer term archive. So as I said, we're very much at the beginning. A lot of what I've talked about probably isn't a clear picture in your mind, is partly because we're working with sustainability science researchers right now to try to figure out how might some of these concepts look in something that we would actually develop using existing tools. So we have funding to develop a prototype in 18 months. If we're not successful, we will wind down. We're focusing on working with researchers in the Upper Great Lakes area, particularly in hydrology, agriculture, to kind of develop some of these concepts, put some things in front of them, get their feedback. And then if we're successful in years 3 through 5, we would sort of grow out in terms of the types of data, the users, functionality. So in other words, we're not ready to, we don't have an infrastructure that exists as a place for you to put your data, but we would very much welcome, if you are in the area of science of sustainability research, to have people who would be willing to work with us to help us sort of make real what SEED might look like. Also welcome comments from people in technology and computer information science. It's really much an open slate, I think, as you can see. So in summary, SEED wants to deal with some of these challenges by providing tools and services to work with data as they evolve. Recognizing that data change over time, and it's not about just the end products, it's not about just what ends up in a journal article. Want to facilitate that ongoing use of data, help people determine enable researchers to kind of determine as a community what data should be saved, and then provide means for sort of moving data that have ongoing value from sort of active use to longer term preservation. And we do have a website that is up now, so if you want to learn more about it, I invite you to go there. Thank you very much.
Don't be shy.
So I come from a research group where we do 100% simulations, and maybe in the course of writing a research paper, you do 1,000 simulations, and maybe over half of them just lead to dead ends. And then maybe the other half go to creating a figure in the paper. And I don't have a specific question, but just if you have any comments about, well, how does data management work into this. And just to put a number on things, we might generate, say, 100 gigabytes to a terabyte of data just for one paper. And if you have any comments on that, I'd be happy to hear them.
I guess I'd be interested to know what you think, you know, in terms of, do you want access to people like other researchers like you, if they've done multiple simulations like that? Do you want to have access to be able to sort of look at what they've done? Do you want access just to be able to run, do you want the code and just to be able to rerun that and do your own simulations? Your question is an excellent one, because I mean, this is a really difficult area for curators and I think in the next talk, Victoria Stodden will be talking about some of this very challenge. But I think you know, as a researcher, you really need to help us kind of figure out, you know, what you would want and what would be valuable to you. So I would be really. Do you have any thoughts about that right now, or?
Let's see, I don't know, right now, I mean, in our field, things are progressing so fast. We're at the point where we can go back and you just from the paper and looking at the parameters and how they set up a simulation, we can rerun someone's entire PhD in a month because the computing is getting so much faster and faster. And my own data sets are so, should I say, disorganized and hard to follow that I wouldn't really want anyone to look at them. And so if we're going forward with these data management plans, I have to think about how am I going to organize these things so that they're going to make sense for someone else. And but you asked the question, what would I want to see from someone else? And I guess I don't really have an answer to that right now. I mean, most of the stuff that goes on in our field, the paper is the summary of, you know, someone's looked at this humongous data set and they've found the patterns in it and have published the plots on the patterns. And, you know, maybe at a minimum, I would want the numbers that went into the plot so that I could reproduce a plot and then compare. But I wouldn't necessarily need the entire terabyte of data that went into it.
Yep. I think those. I think it's important for all of us as, you know, research communities and in my own research community as well to have these, to think about these things and to use them to sort of drive what their requirements should be in these data management plans. And it's not that the answer is going to be there overnight or there is, you know, quote, an answer or a perfect answer, but I think that's the way to approach it. You know. I've had, you know, sometimes I think if it's something's really complicated to do, someone is just going to redo it. And like you say, your own work is complicated, so someone may not, you know, actually want to rerun everything, or, you know, actually want to see all the files that you generated, but they just want to be able to understand what you did so they can evaluate it. So providing them with that information instead. You know, I've had other, like in biomedicine, you know, where instrumentation changes so quickly, you know, the data a year from now that you can generate will be, quote, better, and so the likelihood that someone may go back and look, you know, I'm kind of generalizing here, but there are sort of ways that you can kind of think about it, so that was very helpful, thank you.
Hi, I had several questions, actually. One of my first was with regards to IP concerns, not necessarily affecting what you publish. How does that change with the change from first to invent to first to file?
Sounds like an Alex question. Can I punt on that? Yeah. Man, I mean that's like an academic paper right there.
Doesn't first to file essentially mean you have to keep your data secret until you apply for patents?
Right, absolutely, because there's this kind of artifice right now in the patent system with the way that you go about registering your patent. So there's this kind of this assumption that if you're the luckily, we haven't actually made that transition yet to a first-to-file system. But yeah, absolutely. If we were to move to that point, it would completely change the way that institutions or anybody with any sort of potentially patentable information is going to secure that prior to making it available. But yeah, to be honest with you, that's something I'd have to probably punt to OTT. They're definitely our licensing specialists. So you're trying to interpret what the impact of changing that patent scheme would be something that they would probably be better suited to comment on. So ultimately, I'm still going to punt.
Okay. I was just curious. Another concern was you mentioned sort of budgeting for sharing data. And for people who generate large amounts of data, say you end up with a 10 terabyte data set, how can you budget when you may have 2 people interested versus 20,000 people interested in your data? I mean, is there a way later to get funding to share your data after the fact if it turns out you came up with a very,
So I think this is one of the reasons why when people higher up in the university talk about provisioning a long-term data archiving service, there's a lot of discussion of making it a public good. It's one reason. Another reason, of course, is that there's not much incentive in a lot of cases to pay for that. But it is hard to know, of course, in advance how much your stuff is going to be used. One thing that I think would help in that regard, again, is having standardized pricing so that you could actually make some assumptions and then price it out based on those assumptions.
I guess one last question regarding metadata. Were you talking about actually making the metadata within your archival system or within the actual data files itself?
So people do it both ways. Like, some data centers, you submit the data, someone helps you fill in some sort of template for the metadata. Others, it's actual, like, a self-describing data format where it's there in the file header. I think there's just a lot of variation in how that's done. Maybe Anne has some more other examples of that. I think in either case, there needs to be support for it. It doesn't get any easier just because you're putting it in one place or the other.
Yeah, I guess there are some data formats obviously that won't take metadata. So unless there is some sort of catalog or some sort of system we're putting the data into, is there some standard or some way we should be attempting to tag data?
Yeah, well, so there are many standards, and one of the parts of the guidance that we put together for the COE was concerned with helping people select the right metadata standard. In some cases, like in the biosciences, those are huge XML schemas that need to be filled in with great amounts of labor, and there are lots of tricks people use to try and get that to happen. Tranche Project, which you may be familiar with, has done a lot of work around that, just figuring out social engineering methods for trying to get people to fill in metadata, which is kind of amazing. But, standards vary, and of course in a lot of areas there is no standard, so then what do you do? That's a really good question that I don't think we answered to anyone's satisfaction in the guidance.
Thank you, everyone. And there'll be a 30-minute break before our final keynote, which will be in this room.